Hey superstars, welcome to the lesson. We're going to be learning about linear equations, and I don't want you to be freaking out like that lady down there. I want you to sit back, relax, and enjoy, and realize just how easy it is to solve for x.
It's important that we establish the difference between an expression versus an equation. So here I have a statement, the sum of a number and 7. We are realizing that in our algebra, when I am talking about a number, right, it means something that's unknown. We usually associate the letter x to this unknown. It can be any letter, but generally we use an x. So the sum of a number, so I'm going to be adding to this unknown number 7. So that would be an expression, and we can't simplify further. There are no like terms, so that is where I would stop. If I compare this to an equation, the sum of a number and 7 equals 12. So the first part of that statement is just as before. The sum of a number and 7, now here comes the equation bit, equals 12. So we obviously notice that the main difference between an expression versus an equation is that an equation has this equals to side. I talk about the left-hand side and the right-hand side of the equation, and our goal here is to make the left-hand side and the right-hand side look the same, right? That is how we will satisfy the equation. And what we're going to do is we're going to determine, so what must this unknown be so that the left-hand side is equal to the right-hand side? Now, in this instance, it should be quite simple to see. What plus 7 is 12, right? And what most of you should be saying, we know that 5 plus 7 is 12. And that would satisfy the equation. If x was 5, then the left-hand side would be equal to the right-hand side. So we're going to be working with two different methods in order to solve equations. We're going to work with the inverse method or the transpose method. So the lovely thing is that you can use which method you prefer and that you feel most comfortable with. We're going to start off with the inverse method because this is really important. It really illustrates how when we're working with equations, what I do to the one side of the equation, I need to do to the other side, right? We balance the equation. You can't introduce terms, add, subtract, times, divide on the left-hand side and not do the exact same thing on the right-hand side. So remember what we are doing in these questions. We are solving for x, our unknown variable. If I had to use this first method, the inverse method, all right, so I'm going to have 2x minus 5. I'm just going to leave myself a little bit of space here. The first step would be, okay, so I want to be left with just x isolated on its own on the left-hand side. So I don't want that coefficient 2 and I don't want the negative 5. So in order to isolate x, well, I first of all want to get rid of this 5. So if I add 5 on the left-hand side, right, then what will happen is that the 5's cancel each other out. And I'm just going to be left with 2x. But I did say earlier that if I add a term to the left-hand side, as I did now, I need to add that exact same term on the right-hand side. So what I now have on the right-hand side is that 2x is equal to 15 plus 5 is 20. Now I need to isolate x. So I don't want 2x, I want 1x. So if I divide this by 2, what will happen is that the 2's cancel each other out and you're just going to be left with x. Perfect. Remember though, what did I say? If I divide the left-hand side by 2, I also need to divide the right-hand side by 2. If I do something to the left-hand side of the equation, I must do the exact same thing on the right-hand side. So if I divide 20 by 2, I get that x is equal to 10.
And now the really fabulous thing is we can check our work. So what do I mean by that? Well, check this out. If I now sub x equals 10 back into the equation, so it was 2x minus 5 is equal to 15. All right, but we just solved x to be 10. So that's going to be 20 minus 5. Hey ho presto, look, the left-hand side and the right-hand side are exactly the same, right? So you've satisfied the equation. You've solved for x. If x is 10, then 2x minus 5 will equal 15. All right, so the inverse method is essentially what I do to the one side of the equation, I need to do to the other side. If I added 5 on the left-hand side, I add it on the right. If I divide by 2 on the left-hand side, I divide by 2 on the right. Okay, and we just quite clearly see this happening when we're using the inverse method. All right, so let's have a look at the transpose method. So when I say transpose, again, you might be like, oh, what do you mean? Transpose is just another word for transfer. What I'm basically going to do is I'm going to transfer this negative 5 onto the other side of the equation. So the transpose method has perhaps fewer steps, but we still get to the same answer. And the idea, remember, is still we just want to isolate x. So if it's negative 5 on the left-hand side, when you transpose it, when you transfer it, it's going to be the opposite operation. So if we were subtracting on the left-hand side, we are going to be adding on the right-hand side. So that's going to be 2x is equal to 15 plus 5. All right, so transpose, we switch our signs. So at the moment, I have 2x equals 20. All right, and now we need to solve for x. So I'm going to transpose, I'm going to transfer that 2, right? I don't want the 2 in front of x, so what I do is I transpose and I do the opposite operation. Since the 2 was multiplied onto the x, when I transpose to the other side, when I transfer to the other side, I do the opposite operation. So if it was times by 2 to get onto x, now I'm going to divide. I do the opposite operation. So therefore, x is going to be equal to 10. And we obviously know that this solution is correct, right? Because I showed you when we did the inverse method how we can do this check. So the wonderful thing about algebra is that we can actually check our solutions, which is awesome. So we know that we are on the right track. Okay, let's do a couple of more examples. All right, so we're going to use both methods. You can decide which you prefer. Okay, let's start with the inverse for 5x plus 3 equals 18. All right, so 5x plus 3. We want to get x to be alone, right? We want to try and get this letter to be 1x equals my answer. So I need to start working around it. I want to get rid of the positive 3 by subtracting 3, right? Because 3 minus 3 is 0. Then remember, if I do something on the left-hand side of the equation, I need to do that exact same thing on the right-hand side. So simplifying both sides now as is, I've got 5x is equal to 15. All right, remember still, our aim is we're trying to get this x to be on its own. So now, since 5 is multiplied onto the x, I want to divide by 5 so that the 5's cancel out. Just how in the previous step, these 3's cancelled each other out. The 3 minus 3 gave me 0. Now 5 divided by 5, I'm just going to be left with 1x. But remember that if I divided the left-hand side by 5, I need to divide the right-hand side by 5. So my answer is that x is equal to 3. And we can even check. So if x is 3, 5 times 3 is 15. And 15 plus 3 is 18. 18 is equal to 18. So the left-hand side equals the right-hand side. You've solved for x. You've satisfied the equation. Cool. So let's compare that to the transpose method.
So remember, the transpose method is just transferring, right? So we're going to take that positive 3. Since it's added on the right-hand side, when we transfer it, we're going to do the opposite operation. We're going to subtract. All right, so it's going to be 5x equals 18 minus 3. We get to, if I simplify that, 5x equals 15. All right, so now we want to transpose that 5 in front of the x. So since it's multiplied onto the x, I do the opposite operation, I divide. So when I transpose, I do the opposite operation, I divide by 5. So therefore, we get that x is equal to 3, right? Which is the same as when we did the inverse method. So we can see that both ways I get to the same correct answer. Let's have another go at this. Let's do 2x minus 4 is equal to, let's work with some negative numbers, negative 16. Okay, and we're going to answer this both ways. It's so easy, right? Okay, so inverse method is we wanting to isolate down to 1x. So negative 4 plus 4, right? That will take me to 0. These two terms cancel each other out. Remember though, what I do to the left-hand side of the equation, I need to do on the right-hand side of the equation. So I'm at the point now where I have 2x is equal to negative 12. Now, to solve for x, to isolate x, I need to divide by the coefficient of x, because then those cancel each other out, and we're just going to be left with x equals. But if I do something to one side of the equation, I need to do the exact same thing on the opposite side of the equation. So solving for x, I get that 1x is equal to negative 6. And if I test that, 2 times negative 6 is negative 12, minus 4 is negative 16, negative 16 equals negative 16. Amazing. The left-hand side and the right-hand side would be the same. So we know that we've solved for x correctly. Let's do the transpose method. So remember, transpose is just saying you're just going to move these terms, right? You're going to transfer them. If it was negative 4 on the left, it's going to be positive 4 on the right. So we're going to have that 2x is equal to negative 16 plus 4. So 2x is equal to negative 12. Now we do the transposing. We are going to divide by 2 so that I can get to x on its own on the left hand side. So x is going to be equal to negative 6. And we see that for both our question 2, we arrived at the same answer. So we know we are correct. All right, and it's really as simple as that, everyone. Let's just have a look at where we have some division going on. So x over 2, or this is the same as saying a half x minus 4 equals 10. So using the inverse method, we are going to start off by, well, you should be getting to the swing of this now. Since it's minus 4, I'm going to add 4 to both sides. All right, so on the left hand side I have negative 4, so I'm going to add 4 to both sides. Why? Because now these 4s have cancelled each other out, and I'm slowly getting to where x is on its own. So at the moment I have x over 2 is equal to 14. Since x is divided by 2, I want to do the opposite operation to get rid of it. So I'm going to multiply the left-hand side by 2, because look what happens. Those 2's cancel each other out. But if I multiply the left-hand side by 2, I must also multiply the right-hand side by 2. So therefore, I get an answer of x is equal to 28. Having a look at the transpose method, so first of all, we're going to transpose, we're going to transfer that negative 4, we change its sign. So if it's a negative 4 on the left, it's going to be positive 4 on the right. So I have that x over 2 is equal to 10 plus 4. So x over 2 is equal to 14. Now that we see, all right, to isolate x is divided by 2 on the left-hand side. So when I transpose, I'm going to multiply by 2 on the right-hand side. So x will be equal to 14 times 2, 28. All right, so we see that whatever method we decide to use, whichever approach we want to take, we get to the same correct answer. Well done, everyone. I hope you enjoyed the lesson and that equations, well, linear equations at least, are making you feel excited and happy and good, because you know what? You are all brilliant, superstars, geniuses of the world. Well done, everyone.